Okay, so welcome to your lesson today. It's following on from the sine and cosine curves that we worked on yesterday. So the starter is hopefully on the board or on the screen, should I say. 4 different questions using different skills relating to right angle triangle trigonometry. So have a go, pause the video, and then the answers will be on the next slide. Okay, so next slide. Hopefully. There we go. So, couple of things. Obviously, the first one here, you needed to work out the missing angle. So once you've got the missing angle, you can then just use sine. The first one on the right, that is all to do with the cosine rule, because you haven't got those opposite matching pairs. Bottom left, you needed to use the area of a triangle. Sorry, my brain's not working. Area of a triangle, half AB side C. And then put them in the formula and get your area. And then the last one, bottom right hand corner, you need to do a little bit of work on ratios and getting A in terms of B in terms of A, which allows you then to work out the length of C. So slightly harder. That would definitely be a grade 8, grade 9 style question there. So just a bit of a reminder about the sine rule and the cosine rule. Okay, now on Monday we are going to look a bit more at the sine rule when we're looking at exact values. So today's lesson, or actually even before we get started on today's lesson, let's just have a go at these 4 questions. Now this is definitely just what we were doing yesterday, just to remind us, get our brains going this morning. So 4 questions. If you could solve them, I'm interested in the answers between 0 and 360 degrees. Okay, so 4 questions. Have a go. Be careful with that negative one. I did explain a bit about that yesterday in our lesson. For the sine x equals minus 0.21. What I will do, if you pause your video now, I will explain how to work them out. I just talk through them in a minute. Okay, so the first one, sine x equals 0.7. Now, before I would even start, I would have a little drawing of my graph. Okay, not very good, sorry, but right, it will help us work it out. So if you put inverse sine 0.7 in your calculator, you get your first answer of 44.4 degrees. So basically we're at 0.7. Obviously, it's going to be one of those days. So hopefully you remember the graph goes up to 1, so 0.7 is about there, and that will give you 44.4 degrees. Now, because it's symmetrical around 190, this value here is 180. So to get this value here, just following across, what we need to do is 180 take away the 44. So that gives us our other value, which is 135.6. So we've got our 2 values for that one. Okay, now I'm going to leave that on there because what I am going to do is we're going to do the next one. So again, tap it into your calculator. Now, when you do inverse sine of minus 0.21, you actually get an answer of minus 12. It's actually 12.12, but let's just work with 12. Minus 12, should I say? And that's because the graph carries on down here. And what you've done is you've looked at minus 0.21, which has given you the principal value here, which is minus 12. Now, obviously, that's not within our range of 0 to 360, but if we follow that across, we want this value and this value. Well, this value here is basically 180 plus your 12. So that gives us 192.12. It was actually 1212. Okay, degrees. And then this one here is because it finishes or doesn't finish at 360, it gets back to it completes a cycle at 360. So we need to do 360 take away 12.12, so it gives us 347.88 degrees. So we don't need that as our answer. That was just our working value. Our two answers are 192.12 and 347.88. Okay, so on to the cosine one. Or ones, there's two of them there, isn't there? Let's actually do a quick sketch of cosine. Now, I always remember the cosine always starts at 1. It goes down to 90. Let's see if I can actually draw it better than I drew the last one. No, can't. Okay, so obviously symmetrical, starts at 1, finishes a complete cycle at 1, crosses at 90, and at 270 with our line of symmetry at 180. Okay, so that's the cosine curve. You've probably got them drawn out from yesterday. Now, 0.85. So cosine of 0.85 is basically that value there, which you tap into your calculator. I think gives you 31.8. Let me just check that. Sine 0.85. Okay, yeah, so 31.8. So that's that value there. Well, that value also occurs over here. If we were to track that line all the way across, there even. Okay, it's not very symmetrical. It should be. So basically this distance here, from 360 back down to our value where it meets, that's 31.8. So you need to do 360 minus 31.8, which will give you the other value. So we've got one value at 328.2 and the other value 31.8. Don't forget these are all degrees. And then we need to do exactly the same with the negative. So shift cosine minus 0.85. Okay, so this time we're down here at minus 0.85 and we're getting a value of 148. So one of our values, or our principal value, is 148.2. Now we can do exactly the same. We can do 360, take away 148.2, which gives us 211.8 degrees. Okay, so we've got our two values from our one equation, but that's because we're working between 0 and 360 degrees. Okay, so that was kind of a bit of a follow-up from yesterday and the day before. We are going to look at the tan curve now. So what I would like you to do is complete the table opposite. Now, to complete the table opposite, this is what we are doing. We're doing y equals tan of x. So basically, on your calculator, you can do tan of x. So tan of 0, well, tan of 0 is 0. Then do tan of 1, which gives you, 0.017. Then do tan of 15. You get the idea. And I would leave it, well, you can leave it as 2 minus root 3. Which is how my calculator's given it. It's a lot easier than writing a load of decimals. Okay, and keep going and complete that table. So if you just pause the video, complete the table, and then we're actually going to plot those points, hopefully. Okay, so hopefully you've completed the table. Here's one I prepared earlier. I feel like a Blue Peter presenter. There we go. So you've completed the table and you can see various things happening. When you did tan of 90, you may have got a bit confused because obviously it gives you maths error. It's not possible. Exactly the same down here when you did tan of 270. And I'll explain why that's sort of happening in a minute. So some of you may have actually already figured that out. Now, what we are going to do is we're going to plot these points on a set of axes. So you do need to have this set of axes set up. So we're basically going to draw y equals tan of x. Okay, now notice it goes from -4 to 4 now. It's not just going from -1 to 1, so slightly different. Now, let's have a look. I'm not going to plot all the points, but you'll get an idea of what's actually going on. So at 0, 0, we've got a point. Then 1, 17. Okay, well, I'm not even going to attempt to plot that, but 45, 1 is going to be there. And as we get closer and closer to 90, it gets bigger. Look, we got at 89, it's 57, which is right off our chart. So actually, what we've got is a curve. Now, it doesn't cross 90, so it basically goes up like that. Okay, and 90, there is no value. So I'm going to put the dotted line. I'll explain what we call the dotted line in a minute. Now, just after 90, it's really, really small. It's right down here. So at 91, it's -57. 135, which is in the middle, it is a -1. No, where's -1? Sorry, there. Okay, what have we got for 180? It's 0. Okay, and then as we get closer and closer to 270, to 269, it's really, really big again. Is there any points obvious? So 225 is 1. But then when we get to 270, we've got another dotted line where it doesn't actually have a value. So your curve, and this is where it's all going to go horribly wrong, looks like... That's better than I thought. Right, okay. Looks like that. After 270, you'll see it's back down here again. And again, it goes up, keeps on going, until we get to the next dotted line. So it is a repeating pattern. And those people who are going to go on to A-level will use the identity that tan x is equal to sine x over cos x. And the reason why we've got these dotted lines is because you can't divide by 0. Okay, so that's basically where the cosine curve is 0 and you can't divide by 0, hence you don't get a value. Okay, so that kind of explains the dotted line, but you do study that a lot more when you go on to do your A-levels. So that's your y equals tan x curve, and you can see it basically repeats every 180 degrees. Okay, so when you're working out values, all you need to do is either add on 180 or take away 180, because this value here is basically moved up by 180 degrees. Okay, but you've also got values greater than 1 and -1. Sine and cosine curve are limited between 1 and -1, whereas tan, you can actually have, it goes a lot larger than that. Okay, so I did put in, just in case my graph didn't go very well and you couldn't see it, a slightly better diagram. Okay, and you can see that it repeats as it works its way up. So we basically did from here to here, but you see it just keeps going. And I've also put there that the sine x, tan x is equal to sine x divided by cosine x, which is why we kind of get, well, which is why we get these dotted lines, these asymptotes they're called, which are basically lines on a graph where there are no values. Okay, so quite a lot to take in there, but it does just build on what we've been doing. Now, this is sort of one of those questions right at the end of the exam paper. So it might come up, might not come up. It's certainly not a guaranteed. Someone else asked yesterday in the chat whether we do anything else with these graphs. Well, we do. We do some graph transformations, which we will probably, well, which we will be going on to either next week or the week after. So for today's lesson, we've had a bit of an introduction there into the tan graph. What I would like you to do, I've put on some mixed exam questions based on sine, cosine, and generally the questions are on sine and cosine, but you might get one on tangent, so you did need to know about that. So they're cool bit maths. I've also attached the answers, so please work through those. Obviously, any questions, please just put in the chat. More than happy to help you, and your feedback in your learning review is also really useful. Okay, so any questions, please fire to me, but any feedback also gratefully received. Okay, So that's the introduction to your lesson today, and I hope you found it useful.